I'm Hyacinth Megapino, and I'm here to discuss 3 problems in Chapter 24, Capacitance and Dielectrics, as part of our requirements in Electromagnetism for teachers. So let's start with the first problem. This is from 24.2, which deals with capacitors and capacitance. The problem is, the plates of a parallel plate capacitor are 3.28 millimeters apart, and each has an area of 9.82 centimeters squared. Each plate carries a charge of magnitude 4.35 times 10 to the negative 8 coulombs. The plates are in vacuum. What is A. The capacitance, B. The potential difference between the plates, and C. The magnitude of the electric field between the plates? So, before solving, let us first enumerate the given. So we have the distance, which is equal to 3.28 millimeters, and we need to convert this into meter. So we'll have 0.00328 meters. We also have the area, which is equal to 9.82 centimeters squared, and once converted into meters squared, we will have 0.000982. And lastly, we have the charge, which is equal to 4.35 times 10 to the negative 8 coulombs. We are first asked to find the capacitance. And in order to do this, we need to use the equation C is equal to epsilon naught A over D, wherein A is the area of the capacitors, and D is the distance between the capacitors. So, of course, we know that the epsilon naught is constant, and it has a value of 8.85 times 10 to the negative 12 farad per meter. And once we substitute all the needed values in the equation, we will get the capacitance, which is equal to 2.65 times 10 to the negative 12 farads. Next, we are asked to find the potential difference. And in order to do this, we need to use the equation C is equal to Q over V, wherein Q is equal to the charge and V is equal to the voltage. But since we are required to look for the voltage, we need to manipulate the equation, and thus we will get V is equal to Q over C, wherein Q is the charge and C is the capacitance. Our Q is part of the given, and the charge is what we solved in the first part of the problem. So we need to substitute these values, and once we do that, we will get a value of 1.64 times 10 to the 4th volts. And this is the value of our potential difference. So for the last part, we are asked to find the magnitude of the electric field. And in order to do this, we need to use the equation V is equal to ED, wherein E is the electric field and D is the distance between the plates. But we need to once again manipulate the equation in order to get the electric field. So once we do that, we will get E is equal to V over D, wherein V is the voltage and D is the distance between the plates. We obtained the value of the voltage or the potential difference in part B of this solution. So we need to substitute that into the equation along with the distance. So once we do that, we'll obtain the magnitude of the electric field, which is equal to 5.00 times 10 to the 6th volts per meter. So that is the answers for our first problem. So the next problem is from item 24.45, which deals with Gauss laws in dielectrics. The problem is, electronic flash units for cameras contain a capacitor for storing the energy used to produce the flash. In one such unit, the flash lasts for 1/675 seconds with an average light power output of 2.70 times 10 to the 5th watts. In part A, if the conversion of the electrical energy to light is 95% efficient and the rest of the energy goes to thermal energy, how much energy must be stored in the capacitor for one flash? Part B, The capacitor has a potential difference between its plates of 125 volts when the stored energy equals the value calculated in part A. What is the capacitance? So, just like the first problem, we need to enumerate the given. So we have the time, which is equal to 1 over 675 seconds, or it can also be written as 1.48 times 10 to the negative 3 seconds. We also have the power, which is equal to 2.70 times 10 to the 5th watts. And lastly, we have the voltage, which is equal to 125 volts. We need to find the energy first. So in order to do that, we need to use the equation P is equal to E over T, wherein P is the power, E is the energy, and T is the time. But since we are asked to find the energy, we need to manipulate the equation, and once we do that, we will have E is equal to PT. Upon substitution, we will get the value of the energy, which is equal to 400 joules. But this is not the final answer yet. Take note that in the problem, it was stated that the conversion to electrical energy, or the conversion of electrical energy to light, is 95% efficient. So therefore, the 400 joules is only the 95% of the total energy. So we need to find the total energy that is needed to be stored. And to do that, we only have to multiply, or we only need to use E is equal to the percentage multiplied by the total energy. And to get the total energy, we need to manipulate the equation. So we will get E, which is the value that we got, and this will be divided to 0.95, which pertains to its 95% efficiency. So upon substitution, we will get U is equal to 421 joules. So this is the total energy that is needed to be stored in the capacitor for one flash. So the next thing is the capacitance. This one is actually quite easy. We only need to use the equation U is equal to 1/2 CV squared, wherein U is our total energy, C is the capacitance, and V is the voltage. But since we need to find the capacitance, we once again need to manipulate the equation, and we will get 2U over V squared. So we need to substitute the values for the U, which is equal to 421 joules, and for the voltage, it is 125 volts. Take note that we have to square the value of the volts in order to find the value of the capacitance, which is equal to 0.054 farads. So that's it for problem number 2. So we are now down to our last problem, and this one is from item 24.55, and this has an average difficulty. Just like problem number 2, this also deals with Gauss laws and dielectrics. So the problem is, in figure E24.20, C1 is equal to 3.00 microfarad, and the potential difference between points A and B is equal to 150 volts. The charge on the capacitor C1 is equal to 150 microcoulomb, and the charge on C3 is equal to 450 microcoulomb. What are the values of the capacitance of C2 and C3? Okay, so before solving, we need to enumerate all of the given. This is actually something that I do as a technique, sorry, not just because I am after the extra points, but because once you list down all of the given, it will be easier for you to evaluate the problem. So we have C1 is equal to 3.00 microfarad, V sub AB is equal to 150 volts, Q1 is equal to 150 microcoulomb and Q3 is equal to 450 microcoulomb. We are asked to find, of course, the capacitance of capacitor 2 and capacitor 3. But before we proceed to the solution, it is important to note that the capacitors in series carry the same charge and capacitors in parallel carry the same potential difference. These reminders are important, especially when dealing with problems like this one. So this is a very long process, and we need to start by finding the voltage of capacitor 1. So in order to do that, we need to use equation V is equal to Q over C, and our Q will be our Q1, which is equal to 150 microcoulomb, and our C is the capacitance of capacitor 1, which is equal to 3.00 microfarad. Upon dividing the two values, we will obtain a value of 50.0 volts. Going back to the figure, we can see that capacitor 1 and capacitor 2 are actually connected in parallel. It means that these two capacitors have the same voltage. So our V1 will be equal to V2, and both of them will have a value of 50.0 volts. So now we are only down to the last value, which is the voltage for capacitor 3. And in order to get this, we need to subtract the voltage in points A and B with the voltage that we obtained in capacitor 1, which is equal to 50. So 150 volts minus 50 volts is equal to 100 volts. So that is our voltage for capacitance or capacitor 3. So because of this, we can now solve for the capacitance of capacitor 3. And to do this, we need to use the equation C is equal to Q over V, wherein Q is a charge and V is a voltage. The charge of capacitor 3 is equal to 450 microcoulomb, and its voltage, as what we have solved, is equal to 100 volts. Dividing these two values, we will obtain a value of 4.5 microcoulomb. So since we already have the value of the capacitor 3, now we will proceed to the value of capacitor 2. But in order to do this, we first need to find its charge. So to find the charge of capacitor 2, we have to subtract the charge of capacitor 3 with the charge of capacitor 1. So 450 microcoulomb minus 150 microcoulomb is equal to 300 microcoulomb. So that is the charge of our capacitor 2. We need to substitute this to the equation C is equal to Q over V. So we will have 300 microcoulomb all over 50.0 volts is equal to 6.00 microcoulomb. So as our final answer, our capacitor or our capacitance in capacitor 3 is equal to 4.50 microcoulomb, and capacitance for capacitor 2 is equal to 6.0 microcoulomb. So that's it. Thank you for your time, and if you have any question, you can email me at hyacinth_camino@dlsu.edu.ph. Bye and stay safe.